Assalamu alaikum. So in this video I will solve this equation, and if you see carefully that this is a first order linear differential equation where p is the function of x, q is also the function of x. So in this video what I will do, first I will find the formula. Okay, we will derive a formula that how to find y, and then we will solve the circuit using our formula. So at the first part we have a pure mathematics here. Pure mathematically we will see how to solve this equation, and then we will solve this circuit using this formula, and then we will check our answer is right or wrong using our phasor as we triple students do it. Okay, so let's start. So let's write our equation dy by dx plus py is equal to q, right? Okay, so now let's multiply by e to the power p dx. Let's multiply by e to the power p dx, dy by dx plus e to the power p dx, py is equal to q e to the power p dx. So I think you might be wondering that why I have multiplied this thing, right? So let's see. Let's try to find the value of the left hand side. Let's see what is this. Okay, so to do this, now I need to find the equation. I need to find differentiation of y e to the power p dx, and let's see that differentiation of this thing matches with this or not. Okay, so let's start. So if I differentiate this thing, I will get, first take y here and only differentiate this thing, so you will get d by dx e to the power p dx, and then write a plus here. This is simply uv rules, right? Differentiation of uv, easy. So first write e to the power p dx here and only differentiate dy by dx. Okay, now we know that how to differentiate this thing. First you need to write e to the power, that power, and then you need to again differentiate that power, right? And this is the basic formula we know. Okay, and now that in the same term we have differentiation and integral operator simultaneously, so these two operators will cancel out and we will only have p here. So y e to the power p dx, then here e to the power p dx dy by dx. Okay, now let's check this thing here. Okay, so now let's check this thing. What is this part? See, this is equal to this or not? This thing is simply is equal to this, and then tell me what is this? This is simply is equal to this, right? That means this term is equal to this term and this term is equal to this term. That means this thing is nothing but this. And what is this? This is simply d by dx, this y e to the power p dx, right? So we can put this thing inside this box. So let's write this thing. So we can write d by dx y e to the power p dx, sorry, okay, and this is equal to q, let's see, q e to the power integration of p dx. Okay, and this is our formula. Let's take this differential operator at the right hand side, and if I do so, I will have a integration here. So q e to the power integration of p dx, and don't forget to write a c here. This will be important, you will see when I will solve the circuit. So y e to the power p dx. So this is our basic formula, and using this basic formula we will now let's solve the equation. So let's say we have a sinusoidal voltage source here, it's a resistor, and we have a capacitor, capacitance C, resistance R, and source voltage is equal to Bm cos omega t. Okay, so now let's solve this equation, find the voltage of V, and to do so we have to write some equations. So this is current I. We know that I is equal to the capacitor's current is C dV by dt, and the same current is flowing through this resistor, and if I take this thing as ground, so this point's voltage is simply Vs. So if I use Ohm's law here, I will get Vs minus V divided by R. Okay, so this is equal to Vs by R, then V by R. Now divide this equation by C, divide this equation by C, divide this equation by C. Okay, now write this thing at the left hand side, then I will get dV by dt plus 1 by RC into V, then Vs divided by RC. And if I write the equation dy by dx that I have written previously, then you can clearly understand that V simply is equal to y, t simply is equal to x, then p simply is equal to 1 by RC, q is equal to Vs by RC, right? Vs by RC. And what is Vs? This is the source voltage Vm cos omega t. So Vm cos omega t divided by RC. Okay, so now let's write out equation y e to the power p dx, then q e to the power integration of p dx plus, don't forget to write this c. Okay, so now put our values here. V instead of y e to the power 1 by RC into dt, q is equal to Vm by RC cos omega t, then e to the power 1 by RC into dt plus c. Okay, so this is simply if you integrate this thing, you will have simply 1 by RC into t, then write this constant outside the integral operator, then I will have cos omega t, integrate this, simply it will become 1 by RC t plus c. Okay, now let's assume that this thing is simply is equal to I. Okay, we assume that this term inside the box is I, so I is equal to integration of e to the power t by RC into cos omega t. Okay, so let's find the value of I and then put this I in this equation. Okay, so this is a simple formula. We know the formula I is equal to integration of uv dx, right? Okay, so how to solve this equation? We first need to write, okay, let me write this equation. This is u and this is v, and this is, let's say, dx. So what is the equation? First we need to write u as it is and integration v dx, then we have to take minus here, differentiate u, and again integrate v. Now put a plus here, differentiate again, but don't integrate this thing, write as it is. Why? Because now you have to stop this series here, and if you don't stop it here, it will goes up to infinity, right? So this is our basic formula. Okay, now using this formula, let's put our equations. U is e to the power trc, and integration of cos omega t will becomes cos sin omega t by omega. Okay, so now differentiation of e to the power trc will equal to 1 by RC e to the power t by RC, and if I again integrate this thing, I will get omega, again another omega. If I let me write this omega here, and if I integrate this thing, I will get minus cos omega t and again omega. Okay, now put a plus here, I have to again differentiate it, right? Du by dx, I have to again differentiate it. So let's differentiate this again, then 1 by RC, this 1 by RC have to simply write here, and again I will get another 1 by RC for differentiating this thing. And you see that I have to these two things are same, that means I don't need to further integrate this thing, so write as it is here. Okay, so now let's then write here okay, a long series, right? Okay, no problem. Now what I will do, let's write this I here, then take this term at the left hand side. Okay, take the last term at the left hand side, then we have a minus here. So if you take this term at the left hand side, I will get a plus here, and then 1 by RC means RC square, and you have 2 omega, right? So we have omega square. And see one thing, that e to the power t by RC and cos omega t integration of dx of e to the power t RC cos omega t, simply it's I, right? Integration of e to the power t by RC cos omega t, see, e to the power t by RC cos omega t integration of, it's not dx, it's simply dt, it's dt. Okay, it's dt. Okay, so this is simply is equal to I, so right here I, and then I have take common e to the power t RC, e to the power t RC, then write sine omega t by omega plus 1 by omega square RC cos omega t. Okay, no problem. Now let's multiply. Okay, so now let's multiply both equation by omega square r square c square. Okay, so multiply this both equation by omega square r square c square, then I will have here omega square r square c square, and here I will have only I, e to the power t by RC. If I multiply this with omega square r square c square, okay, let's first multiply this thing and put it, let's first multiply this thing. So if I multiply this second term with omega square r square c square, I will simply have RC cos omega t, and then again multiply this thing, I will get omega r square c square, then sine omega t. Okay, so now I is simply is equal to 1 plus omega square r square c square, right? The coefficient, let's take it here, so you will get this. Okay, so e to the power t by RC, and take RC common here, so we will have cos omega t plus omega RC sine omega t. Okay, okay, so now let's put this I where? Here. Okay, so let this put this I here. So v e to the power 1 by RC into t, then bm by RC. Now it's I, okay, a big I, e to the power t by RC into RC cancels out, and then cos omega t plus omega RC sine omega t plus c. Okay, now I will use another thing here. So this is our answer. We can stop here, but we want to simplify this equation again. Okay, so we can check our answer is wrong or right using the phasor. So let's do this. Okay, so the coefficient of cos omega t is 1 and sin omega t is omega RC. So let me write a triangle here, and let's assume that this is theta. So if I assume that the base of this triangle is 1 and this perpendicular direction we have omega RC, then the hypotenuse will be equal to 1 plus omega square r square c square. Okay, okay, so v e to the power t by RC, bm e to the power t by RC. Okay, now let's split this thing. Can we write this thing like this, root over 1 plus omega square r square c square, and we have another root over here, right? And let's do another thing. Okay, let me write this equation and then you will pause this video and see what will happen. Okay, then again omega RC 1 plus omega square R square C square sine omega t. Okay, now think carefully. Can I write this thing equation from this equation? Yes, right? Okay, if you don't understand, you can pause the video, you will understand it. It's very easy, right? It's a very easy thing how I have done this. Okay, so what is this? First tell me what is this. From here, from this triangle, we can simply write that this is equal to sine theta, right? And what this thing, from this equation we can simply call this is cos theta. Okay, so here e to the power t by RC. Oh no, we can't write this thing now. Don't forget, here we have a c here, right? We have a c here, I didn't write here. Okay, so v e to the power t by RC, then Vm divided by root over 1 plus omega square R square C square, then e to the power t by RC. Okay, so now you have a formula cos sine. We can simply write it like cos omega t minus theta, where theta is simply is equal to, from this equation we can write tan inverse omega RC divided by 1, right? And here Vm root over 1 plus omega square R square C square e to the power t by RC. Here we have a constant c, and then v e to the power t by RC. Okay, now if I divide this equation by e to the power t by RC, then this t by RC will be cancels out, then cos omega t, we are dividing by e to the power t by RC, right? Then I will have a this thing, right? Okay, so as we are a triple student, we know that our equation can be divided into two parts, right? These are like two we can split our solution into two parts. So what this thing is, the natural response, and this is the forced response, right? So this is the natural response and this is the forced response. Okay, so now we will solve this equation using the phasor. Okay, so let's do it. Let's see how to do it with phasor. Okay, so now let's do this thing using phasor and let's see what happens. And you see that our voltage has lagged by theta. Our voltage has been lagged by theta. As capacitor we have used the capacitor here. We know that capacitor contributes to lead the current, but its voltage becomes lagged, right? Okay, let's see by using phasor. So we have a circuit here, and for phasor we will have here Vm 0 degree, then we have a resistor, and then we have a capacitor here, and the impedance of this capacitor is 1 by j omega c. And now I need to find the voltage of capacitor, so I have to simply write a voltage divider rule. So 1 by j omega c, then R plus 1 by j omega c. What is this? It's simply voltage divider rule, right? Okay, so now by simplifying this thing, I can write, if I multiply by j omega c in numerator and denominator, I will get an equation looks like this. Okay, so this is our phasor equation. This is our phasor equation. But if I now wants the voltage, instantaneous voltage, which is a function of time, then it's have a magnitude and it also have a theta, right? Phase, sorry, cos omega t plus theta, right? So now I need to find the magnitude of this. So 1 by v is equal to simply 1 by omega square r square c square. Okay, and now how can I find theta? Theta is simply, we can find it by, let's see, this is 1, and what is the how can I say this thing? Okay, just forget it. If I find theta, I will get, as it is at the denominator, I will have to write here minus, then I need to write tan inverse omega rc, right? So v is equal to 1 by omega square r square c square, then cos omega t minus tan inverse omega rc. Okay, so you can see that this is the forced response. This is the forced response, and it becomes equal to this. You can see that bm by, okay, let me zoom out this thing. Okay, so this thing is simply is equal to this, right? Okay, and then we need to find the natural response, and to find natural response we have to shut off this voltage source. And to do this, let me write this here again. And to shut down this voltage source, we need to simply make a short circuit here. Okay, and if you learn DC circuit, you know that it's simply the voltage is equal to V is the initial voltage V naught, then e to the power minus t by RC, right? So this is our initially charged. So what is B naught? B naught is the initially stored voltage, initial voltage of capacitor. That means when t was equal to 0, the voltage across this capacitor was V naught, right? That means this is our natural response. And from here we learned this, what is this V naught? So what is this C? What is this C? Oh, I am very sorry. No, I am very sorry. So this is not the right technique to find the, wait. So what I am claiming that now I need to find C, right? So what I will do, let me write this equation again. Let me write this equation, which is a function of t. We have Vm, then 1 by omega square r square c square cos omega t minus theta, where theta is equal to tan inverse omega rc, right? And then I have C e to the power minus t by rc. This C is not capacitance, this C is a constant. Hey, what's going on with my laptop? Okay, so this C is not capacitance, this C is constant. And how to find this C? You have to simply put t is equal to 0 here. And if you know that when t was equal to 0, the initial voltage was, let's say, V naught. Okay, so by this equation you can find C. So how can you find, let's say you have a voltage source here and you have a capacitor. So somehow you need to find when voltage was 0, what was the voltage across this capacitor. Let's say the voltage across this capacitor was V naught. So now you have to put this V naught here, and then this will be equal to Vm over 1 plus omega square r square c square cos minus theta c, and t is equal to 0 becomes e to the power 0 is equal to 1. So from here you will find a C, and then you have to plug this C here, then you can find the final version of V. Okay, so sorry for the interruption at the middle of this video, but I hope you understand this thing. Okay, thank you.